There we go. 6, 4, 3.
I got a 5, Andrew.
I didn't get a 5.
No, I did.
You got a 5. I didn't get a 5 in that countdown.
There you go.
How bizarre. How truly bizarre.
It's truly bizarre. That's correct.
Okay. All right. We're up and running. And hello to everyone who's joining us live on the interwebs. And those people would have been alerted as soon as we clicked record, I think. Right. Although I can't find it. I don't know why it doesn't work on mine.
Is there anybody there?
Is there anybody out there? That's Pink Floyd. Okay. I'm good to go. Oh, I took some more photos of the moon the other day, Fred. Not overly happy with them. I was trying my Barlow lens for the first time.
All right, so yeah.
Looking through the lens at the moon was extraordinary. Getting right up close and seeing it like I've never seen it before. But then switching the camera and trying to get focused is very difficult.
Yeah.
Found that I'm going to have to keep practicing. I'd probably be better off waiting for it to get higher in the sky because I was taking it as it rose, and you've got to go through a heck of a lot of atmosphere to get a photo. But just a raw image looked good, but for some reason the camera was playing tricks on me.
It's actually the optics of Barlow lenses they're a bit more complicated, so you've got a few things working against you.
Yes, I found that out the hard way, but I'll keep practicing. I'll figure out a way. Now, we've got to do our TikTok. You ready?
All set.
All right. In 3, 2, 1. Hello, my name's Andrew Dunkley, the host of the Space Nuts podcast. And every week we talk astronomy and space science. And with me, as always, is Professor Fred Watson, astronomer at large. Fred, what's on the next show?
Oh, we've got a bumper show for this week. We were going to talk about probably the big news of the year, the fact that we have now seen an image of the event horizon of the black hole at the center of our galaxy.
Yes,
courtesy of the Event Horizon Telescope, and from distant monsters to nearby interest, we're going to talk about seeds being grown in lunar soil.
How fascinating. Yes. We're also going to answer audience questions about dark matter and star populations, amongst other things. Hope you can join us on the next edition of Space Nuts. Look for it on your favorite podcast distributor, episode 305.
Oh.
Okay. Hugh may be able to work with that.
Don't know anybody else who could. I'd forgotten it was 305. Yeah, we should be doing questions, shouldn't we? Never mind. That's all right.
That's all right. We've been doing extra ones, so.
We have, yes. We've thrown in a lot. That's fine.
Okay.
So what's happening?
All right. I am pretty well ready to begin.
Good.
So we might as well get started. Here we go. In 3, 2, 1. Hello, once again. Thanks for joining us on Space Nuts, where we talk astronomy and space science. It's episode 305. And coming up on this program, we're going to be looking at something that's broken overnight in the news, our time, about unidentified aerial phenomena. For the first time in 50 years, they're holding a congressional hearing into these objects that have been observed. And Fred and I have talked about them before. Fascinating stuff. We're also going to look at, almost literally, Sagittarius A. They've finally got an image of the black hole at the center of our solar system. Well, God, we don't want it there. The center of our galaxy. And growing plants in lunar soil, it has happened. We'll also be answering questions about dark matter, the future of astronomy, and star populations. That's all coming up on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me, as he always does, is Professor Fred Watson, astronomer at large. Hello, Fred.
How are you doing, Andrew? Good to see you.
You too. We were kind of in the same vicinity on the weekend. Did you get to Coonabarabran?
No, I didn't.
Oh, well, we weren't in the
So
same
we weren't.
vicinity then. I was
No,
only...
what happened? What happened was the event that I was coming to Coonabarabran for was cancelled because of an outbreak of COVID. So
Of
I
course.
didn't make it.
Always the way. Well, I was only 40 kilometres down the road at a little village called Turawina. Friends of ours were staying in the caravan park there, so we went up to see them and spent the weekend there. What a lovely, sleepy little town it is. We went,
gorgeous,
they had a
isn't
bit
it?
of a fundraiser on at the pub that night, so we went along there and we thrashed our wives at a few games of pool. And I got the most amazing image of the moon through the clouds as it rose, and it just it looks like a painting. I don't know how it worked out that way. I took that with my iPhone. It looks extraordinary. I've put it on the Space Nuts Facebook page if anyone wants to have a look at it. Yeah, just one of those photos that turned out well without any planning whatsoever. Okay, Fred, let us get to business. And this is news that's been breaking overnight, which we've talked about before. These, they used to call them UFOs. They're now called unidentified aerial phenomena. And they have reported over 400 of these in recent times. And we're talking as recently as 2021. And most of these have been seen by naval personnel flying off the coast of the United States. And it's led to this congressional hearing, the first of its kind in half a century, according to the reports I've read. And the people involved have been asked fairly straight questions by the panel about what these things are. And it's got a lot of people scratching their heads still.
Exactly. And yes, you're right. We've talked about this before. Last June, almost a year ago, basically the Pentagon, in fact, it was from the Office of the Director of National Intelligence, they released a preliminary assessment on unidentified aerial phenomena, which was quite an interesting read. And you and I spoke about this at the time. There were 144 reports, many of which came from service personnel, as you said, Navy pilots typically, about unidentified objects, often seen moving at great speed and doing things that, in terms of their maneuverability, that most airframes wouldn't be able to stand because the G-forces will be too high. The interesting news is that of the 144 reports that were in that preliminary assessment, one has been identified, which was apparently a large deflating balloon, in quotes. That's what the conclusion was. But the other 143 of them remain a mystery. And, what's telling about this, and this is really why it's kind of come from the world of hearsay into something a lot more well documented. At least 80 of those 144 incidents were detected by multiple sensors, often infrared cameras and things of that sort. So that has that gave that preliminary report some weight, but since then the number has grown. It's now something like 400 reported incidents. So that's a phenomenal increase. Does it mean that these things are more common? Not necessarily. It might be that people now feel a lot more confident about reporting these things. You can imagine if you're a Navy pilot and you tell your mates, well, I saw a UFO, they're going to laugh you out of court. But now there is some credibility for, much improved credibility for these sightings. We've got a much larger number. The reports are said to be frequent and continuing, and often occur in military training areas or other designated airspace.
It is fascinating, and as one of the chairman, or the actual chairman of this House Intelligence Subcommittee, Andre Carson, has said that he is concerned because he sees them as a potential national security threat, and they need to be treated that way. The people who are answering the questions, or were overnight our time, was the Undersecretary for Defence for Intelligence and Security, Ronald Moultrie, and Deputy Director of Naval Intelligence, Scott Bray. They were quite frank. They didn't shirk the questions, but they were very clear in saying that we don't know. We don't know what this is. We don't know why it's happening. They were asked direct questions about whether or not they've attempted to communicate with these things, and the answer was no. They were asked direct questions about whether or not there has been any wreckage from downed craft found, and the answer was no. But the bottom line is that they are seeing these things. They're doing extraordinary maneuvering far beyond the capabilities of any known aircraft, and they just don't have answers. But they've gone public, which I think is pretty darn extraordinary in itself.
Yes, that's right. It is. It's an extraordinary thing to do, and I guess it complies with the modern view of transparency about these things, because we used to live in a much more secretive world than we do now. Now the internet is there; everybody can find out. I'm interested, Andrew. Did you watch the video of some of the hearings? I haven't had time to do.
I've seen probably 5 minutes of one of the hearings where these questions were asked, and they were answered. But when you don't know the answer, that's pretty easy, I suppose. But
yes.
It does sort of throw up, and look, they didn't offer any explanation as to what these things could have been. And you and I have discussed it before. And of course, a lot of the conspiracy theorists will automatically go to extraterrestrials as the probable cause, but it's more likely domestic. That's my opinion, and that's just the way I think. It's probably some kind of advancement in aeronautics that somebody's developed, and they're out there playing silly buggers, and somebody knows something, and that whether or not they're manned or they're remote control, more likely remote control. It's hard to answer, but I think we can write off optical illusions, seeing they've been detected by machinery.
That's right.
So it comes down to only a couple of possibilities, really.
Well, another one is the some clever hacking of the sensors or something of that sort from outside.
Yes, that's a possibility.
Yeah, I think for anybody who's interested in following this up, I'd thoroughly recommend reading that preliminary assessment that came out last year. It's pretty easy to find, preliminary assessment UAP, and if you want the full details, it's 2021-0625. That was the date when it was actually released, 25th of June 2021. So it's available on the web. It's worth a look.
Yeah, I think there'll be more to come on this.
I do too.
But whether or not we ever get an answer, I don't know. If it's stealth technology, well, it's not, because we can see it. But if it's technology, advanced aeronautical technology that somebody's playing with, they probably don't want many people to know. But why would you pick a restricted naval air region to get out there? Maybe you're trying to stir things up. I don't know. But I'm sure many people will have a lot of theories, some that we haven't even thought of. But it's the fact that they've got a congressional hearing going on about it certainly takes it into a whole new sphere.
Yeah, it does.
All right, watch this space. Now, Fred, let's talk about one of the most exciting pieces of news in astronomy to date. And I know that's a big call, but we did not so long ago talk about the image of a black hole that was created, and we talked about the fact that they were trying to get an image of Sagittarius A, the black hole at the center of our Milky Way galaxy, and they have finally done it.
Yeah, it's it's been a long story, this, because the observations for this, Andrew, were made back in April 2017, and you're right, we did talk about it because the first image that was released, which was in 2019, believe it or not,
wow,
3 years ago, I think it was October, I can't remember. Anyway, that first image was of the basically the shadow of the event horizon in the M87 galaxy, which is 55 million years, so 55 million light years away. And it surprised astronomers actually when that press, because there was a lot of media hype, and I think I sat in on the press release just as I did last week for the Sagittarius A star black hole. But the M87 black hole surprised everybody because it's much further away. We all thought, oh, it'd be much easier to image the nearest supermassive black hole, the one at the middle of our galaxy. It's a pretty hefty thing, 4.1 million solar masses. But it turns out that with 6.5 billion solar masses, the M87 black hole was actually easier to image. So all the number crunching that took place between 2017 and 2019 actually delivered an image that looked exactly like a cream donut, but that's all right. We can put up with that. And what you're seeing there is the material swirling around the black hole and releasing radio waves, but essentially avoiding what you might call the shadow of the event horizon, because what it is this is radiation that's bent by the supreme gravity of the black hole, but doesn't quite make it back into the black hole. So it shines out like this beam with a hollow center. And that's what we saw back in 2019. And I guess everybody's been waiting for the release of data from the center of our galaxy, because we knew that our galactic center black hole, Sagittarius A star, was on their observing list. So we knew that they'd made observations of it, but the collaboration has kept things pretty close to their chests. It was, so there was an announcement, it's about a month ago, saying there's going to be a big press release from the Event Horizon Telescope about something in the Milky Way galaxy. Well, that can only be one thing. So it was in some ways the world's worst kept secret. Just to run through the statistics, yes, it's 27,000 light years away or thereabouts at the center of our own galaxy. It is also swirling material around it, the black hole, at 4.1 million times the solar mass, but in a much more gentle way than what's happening with M87, because M87 is what's called an active galaxy, where the black hole is gobbling up a lot of stuff. Ours is much more modest in its appetite. And so what it doesn't have yet, or at least haven't been observed yet, is these jets of material that are swept out of the black hole's poles because of the magnetic forces that are involved with that. So we haven't seen that, but there's a suspicion that they might be there. There is also a suspicion that this black hole, its poles are pointing towards us, which might make it harder to detect the jets. That was one of the solutions that comes out of the number crunching that's been done for the black hole. So very exciting news. Good to see it. Yes, it still looks like an orange cream donut, but that's fine. Yes. That's what they look like.
Well, I hear they're already working on getting another image. They're pretty keen to keep working on this, so it's not like that's the end of the story. We may well learn more. It's a pretty great achievement, though, getting an image of something that is very difficult to see because of the dirtiness of our galaxy.
Yes, that's right. The dust, the dust between ourselves and the galactic center certainly switches off any visible light observations. You can penetrate in infrared, and that's how we knew the black hole was there, because there are stars that were detected in the infrared waveband, which are clearly orbiting around something very massive. That's what proved the black hole. It produced 2 Nobel Prizes a couple of years ago. What comes next, though, is really interesting, Andrew, because so just to explain, the Event Horizon Telescope is actually a consortium of 8 observatories, or it was when these observations were made, all on one side of the Earth. So Australia is not part of it because our telescopes are on the wrong side of the planet. But they're all linked together in a really interesting way, because you need very precise observation timings and things of that sort. But that consortium has now been joined by other radio observatories, which increases its power. And what is next on the agenda is to make movies of what's going on in our galactic center. So we might see these blobs of energetic material swirling around the event horizon, which they do actually very rapidly at the black hole in the middle of our galaxy, it's a matter of minutes that it takes them to go around once. Whereas in M87, it's a matter of, I think it's days actually, rather than minutes, because it's such a massive black hole. So there is more to come. Yeah, we may even see more stuff this year.
Will the James Webb Space Telescope be able to, because it's infrared, will it be able to do any imaging of the Sagittarius A star?
Yes, I mean, what it will image is the objects around it. There are occasionally infrared bursts of radiation from the galactic center that the James Webb might well be able to pick up. So I think generally, so these wave observations were made at a wavelength of 1.3 millimeters. That's well into the millimeter radio wave band. Now, James Webb is infrared, which is much, much shorter than that. But I think at the long wavelength end, it will see things coming from the galactic center. So yes, we might well see new results.
Fascinating. All right. Incredible news. And it's something we will be keeping an eye on, because I'm sure there'll be more to learn from Sagittarius A star. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson, astronomer at large. Nice.
Yeah, that was two fairly long topics there. So I think
that's okay.
Yeah, lunar soil is going to be a bit briefer.
Oh, that's all right.
Yeah.
Yeah. Okay. Are you ready?
Yes, all set to go.
Okay, here we go. In 3, 2, 1.
Roger, you're loud and clear here also.
Space Nuts.
Now, are you into vegetables? I know a lot of people aren't, particularly children, and there are certain types of vegetables that people really hate, such as broccoli, if you're American, and cauliflower.
Or British.
Or British? Okay.
Yes.
Those sorts of things. I think they've got their own sort of name as a group. I can't, mustard greens or something. I'm not sure. But the reason I mention that is because there's been a study released by NASA. Well, they funded it through the University of Florida to grow plants in soil from the moon. And it looks like they've been successful, Fred.
Yes, that's right. And indeed, it's not broccoli or broccoli, but a seed of a plant that's related to those mustard greens that you were mentioning. Including cauliflower, one of my favorites, I have to say.
I do like it. I love it baked with cheese on top.
Yeah, there you go.
That's the way to do it.
Irresistible, yeah. And I like it raw too. Anyway, that's another story. So this is a plant, and I'm going to screw this up completely, I'm sure, because I'm not a biologist. Arabidopsis Thaliana. How's that?
I would have said it the same way.
Oh, good. Okay. It might be Thaliana. Sometimes you harden the T in TH.
Yep.
Anyway, Arabidopsis is the plant related to mustard greens, and the seeds have been planted into lunar soil, which came back. Actually, I'm not sure which of the missions this particular sample came from. It may even be several of them. I think, in fact, I saw a picture of this last week with little samples of soil in different pots in a laboratory into which these seeds have been planted. So we believe it's from Apollos 11, 12, and 17. But they also, the researchers, as you said, from the University of Florida, also they had a control sample. This is always the way you do things in science. If you can, you have an experiment and a control sample where you think you know what's going on. And the control sample was what's called a lunar simulant, something that is not lunar soil, but is very similar to lunar soil. That was in, the seeds that the control samples were planted in. So the result was that they started sprouting in both samples, both the control and the lunar soil samples, these seeds sprouted within just a few days of planting. The director of the University of Florida's Interdisciplinary Center for Biotechnical Research is Professor Annalisa, it's Paul or maybe Powell. I'm not sure where that name comes from, but Professor Powell or Professor Paul, she said, we planted them, walked away for a couple of days. And then when we first went back to take a look, it was amazing to see that every plant group, all the seedlings germinated. And that's an amazing result, and it tells us something about what biology can do in alien soil.
Yes.
Which may be something that's quite useful.
However,
the result,
I'm going to throw in a however.
Yes,
if the moon exists because of an impact with Earth by another planet or planetoid way back when, we shouldn't be surprised.
We shouldn't. And, that ties in with the fact that the lunar rocks are very, very similar to terrestrial rocks. But what's different is the way those rocks erode on Earth. It's the weathering and tectonic activity that erode the rocks. On the moon, it's just the radiation of the sun and the bombardment of subatomic particles and micrometeorites. And that's actually why lunar soil is so so different from earthly soil, and also so difficult to handle. It is fine and powdery, and as Professor Powell said, it sticks to everything. And that ties in with what the lunar explorers said.
Yes, indeed.
In fact, one of the, I can't remember which one I wrote about this gentleman in Space Warp. One of the lunar astronauts returning from the moon actually had terrible hay fever on the way back because of the fineness of the dust that was brought into the lunar module on their spacesuits. It just sort of covered everything in the lunar module, and that was the first ever recorded case of lunar hay fever.
Isn't that amazing?
It is amazing. Yeah.
Buzz Aldrin described it as walking on slippery talcum powder.
Yeah, I can well imagine. It's just probably the erosion processes that have led to that fineness, even though the raw material is actually similar to what we have on Earth. So the bottom line with the experiment is that in fact the ones that sprouted in the Lunar Simulant soil were more robust than the ones that were in the real lunar soil. So it says, the article I read says, some of the plants grown in the lunar soil samples had stunted roots and leaves, as well as some reddish pigmentation. And of course, everybody wants to know what that is. So it's now, I think after 20 days, these plants were harvested and prepared for further study for things like the RNA in them, ribonucleic acid, is that correct for that? I think the expressed genes patterns apparently sort of told the researchers that yes, it's typical a typical genetic response to a harsh environment. These are the ones that have been found already. And they're talking about harsh environments on Earth, like when the soil has been eroded and some of the nutrients have been carried away by water or something of that sort. Anyway, so in fact, one of the other researchers, Robert Fell, his quotation from this press release is, "Now that we have lunar soil that has been in contact with biology, we can begin to ask the question, how would you and how hard would it be to mitigate any of the adverse reactions that we saw? In other words, how can you make things grow better in lunar soil?" So,
well, I suppose you find out what's missing that's causing the stunted growth and the discoloration, and you add it to the soil, which is what we do on Earth.
Yeah, throw in the superphosphates.
Yes, that might be the way to go. But it sort of prompts a thought in my mind that if and when we do put colonies on the moon, and let's assume they build domes or something to live under, will they maybe be able to grow vegetables directly into the soil.
Maybe so.
Yeah.
Yep. Hopefully it will be just visiting settlements rather than colonies, but you never know. I think I think you're right. We're going to have a permanent presence on the moon, within a few years' time.
Yeah,
that will be
won't
very
be long.
exciting.
It will be. I'm surprised they didn't try potatoes. We know you can grow them on Mars.
We do, yes.
We've seen it in a movie.
Yeah, we have seen,
and he added materials that were lacking in the Martian soil too.
Right.
He did,
which he found somewhere else. I think you and I have spoken about some studies that have shown that potatoes could grow in Martian soil because of the analyses that have been done from some of the lunar rovers. It hasn't been done yet, but no doubt it will one day.
Yes. But cauliflower may be a thing of the future on the moon.
On the moon,
and,
yeah.
I love cheese sauce on my cauliflower, so that's all covered because the moon is made of cheese. It's
apparently, yes.
It's all going to work. But it's a great study. What an exciting thing to discover that the soil actually works. You can grow things in it. It's really interesting stuff. This is Space Nuts. You're with Andrew Dunkley and Professor Fred Watson. I love that story.
It is a great one, isn't it?
Yeah. Bit quirky, bit different.
Yeah, but points the way to all kinds of future discoveries that I'm sure
for sure
we'll be finding.
Okay, well, we'll just get into our questions now. We've got 3 audio questions. We'll just go with the flow, I reckon.
I reckon too.
Alrighty, in 3, 2, 1.
0G, and I feel fine.
Space Nuts.
Time for our question and answer segment where you ask us questions and we say, I don't know. That's how it goes, isn't it, Fred?
More or less, yeah. There's a little bit more to that. It's usually
we actually do a lot of talking before we say I don't know,
and then we follow it with "but I'll make it up anyway."
Yes. All right, let's go to our first question from Mike.
Hi, my name's Mike. I live on Vancouver Island in Canada. Love the show. I had a question about, I guess it'd be black matter and dark energy, I guess. There's a well of gravity where there's something with mass. What if there was an uplifting gravity in the lack of mass? Would that maybe make sense for those problems, like the Voyager slowing down outside of the solar system and universe, the galaxies spinning faster than they should be, and maybe even the voids in between the galaxies making the filaments of an upheaval of gravity pushing things away, and maybe that's why we can't see dark matter and dark energy, because we can only see gravity by its masses interacting with it. Anyhow, that was just a thought. Love your show. Thank you very much.
Thank you very much, Mike. Yes, all right. Some interesting theories, and I think we talked about this before we started, but it's good that people are thinking about this kind of stuff. Because that's how we learn. That's how we sort of start investigating and finding out what's what.
So it is a great question. And I guess we should clarify that what we're talking about is not dark energy, which permeates the whole universe and is the force that's whatever it is that's driving the accelerated expansion of the universe. What we're talking about is the effect of dark matter, because Mike specifically mentioned gravitational wells, the idea that space-time has these wells in it which are caused by matter, and that's what we feel is gravity. And it's a really good picture to have in your mind when you think about these things. Yeah. So I suppose what he's imagining is sort of other wells that point upwards in space-time. So, you've got negative gravity. But nothing that we've ever seen or investigated has led us to that idea of a negative gravity. So dark negative matter, I suppose you'd call it, rather than dark matter. And I think given what we do know about dark matter, because we can detect it, exactly as Mike said, the fact that galaxies are rotating too quickly for the gravity of what you can see in them to hold them together. So there must be something else. That has been well mapped by observations made of distant galaxies and nearby ones, including gravitational lenses, which really allow you to map the distribution of dark matter well. And when you do that, you would, if there was something going the other way, if there was some sort of anti-gravity taking place, you'd see it. You would see its effects. But that has not been discovered. So I think we're still left with the problem of dark matter being some sort of hidden material which only interacts with normal matter through its gravity, maybe interacts with other subatomic particles in a on very rare occasions, and people are looking for those possible interactions. You might get gamma rays coming from collisions between dark matter and normal matter, but that's still a work in progress. And a final postscript to Mike's question. I think when he mentioned Voyager, he may have been referring to Pioneer. I think it was Pioneer 10, which for many years seemed to be leaving its expected trajectory, which threw into question our model of gravity. But that was resolved, it's probably 2 or 3 years ago now, by more careful thermal modeling of the spacecraft. And it turns out that there was, I think, a panel on the spacecraft that was hotter than had been previously expected. And the thermal radiation was actually providing a thrust to the spacecraft, which over time was pushing it off its trajectory.
Isn't that amazing? Just something as simple as that can throw things off course.
Well, when you've got something that's so far away and been going for so long, that's right.
Yeah, maybe that's the answer to diverting asteroids and comets. We put something on to heat them up on one side, and
it is. It's one of the things that's been thought of. Exactly that. Yeah.
Oh, damn! I thought I figured that out.
I think I think what you do is you paint one side of it white, so the other side, releases more heat, and the white side doesn't.
Okay. Are you kidding, or is that real?
No, I've seen it mentioned. Yeah.
Okay.
Yeah. Don't know how you deal with the rotating asteroid.
Hell of a lot of paint.
Yes, it is.
Yeah. Yeah. Although it gives graffiti artists a job, I suppose.
Oh, absolutely. Yes, that's a place for them. Yeah.
Yeah. All right, Mike. Thank you. Let's move on to a question from Kabir, who's in India.
Hi, I'm Kabir, your listener from India. I'm here for an advice. I completed my bachelor's degree in physics, so now I'm looking forward for my post-graduation. So I'm a little bit confused. Should I go for pure physics or astronomy? I'm actually interested in astronomy, so I would like to know the future of astronomy, doing post-graduation solely in astronomy. My parents are pressuring me to go for pure physics, but I would like to do specialization in astronomy. Yeah, you understand. So I would like to know the future of astronomy. That's my question.
Okay. Thank you, Kabir. And thanks for putting us under the pump, because your parents want you to do one thing and you're thinking of doing another. Gee, we're under some pressure now, Fred. So he's done a bachelor's degree in physics, and now he's got to decide whether or not to do his postgraduate studies in physics or astronomy. His heart says astronomy. His parents say physics.
And it's a great question. And first of all, many congratulations.
What is the future of astronomy? Yeah, and yes, definitely congratulations. Well done. That's some pretty heavy duty thinking.
It's a big achievement to get a degree in physics.
Yes.
as I remember from scraping through mine a long time ago. But it's a good question to ask as well, and it's actually a question I face myself, because I did change from when I went to uni as an undergraduate. I changed from astronomy to physics because I got sort of caught up with the idea that astronomy was all about keeping me happy because I was interested in astronomy, whereas physics might be a route to be a more productive member of the community. You know, I might discover things in physics that would be useful to the world at large, and actually find it easier to get a job. So I did. So my degree is actually, in fact, it's a combined degree in mathematics and physics. But that's what happened. I did go to uni to study astronomy, and on reflection, I got back to astronomy anyway because that's where my heart lay, and I, spent my whole life as a working astronomer with a strong bias to physics. And engineering too, because I did quite a bit of engineering in my early career. Worked for a firm that built large telescopes. So I did develop skills which are marketable. I mean, I think that's the bottom line. And you might think intuitively, and maybe your parents imagine this, that a physics degree would get, for example, a physics PhD would give you more job opportunities than an astrophysics PhD. But that is not necessarily true, because there are certainly, opportunities in astrophysics and astronomy which will continue. So the future of astronomy is bright. It's always a tough gig to get into because there are typically more people who want to do it than there are certainly permanent jobs. I still think, though, that if you do for example, a doctorate or a master's in astronomy or astrophysics, you are not locking yourself out of a future career in another area. You're still on track. If you want to become an astronomer, you can, and you meet the required standards, then you will be. It will happen. But even if that doesn't work out for you, there are other opportunities, because astrophysics is basically physics. It's just physics on a big scale, and the computational techniques that are used in astronomy are very marketable in the financial world. You'll be amazed how many people who do a PhD in astrophysics or astronomy and decide that they want to change. They don't want to be academics for the rest of their lives. They go into either industry or finance, and they do very well. So it's not necessarily a make or break decision. And my advice is always follow your heart.
Yeah.
I told my own kids that. Most of them ignored it, but I did tell them that, I would support them if one of my daughters wanted to do archaeology. And I said, yep, I'll go for it. That's fantastic, because she was really interested in it. In the end, she chickened out and did software engineering. But now she's very wealthy, but that's fine. So maybe that was right to ignore my advice. One other comment, if I may, Andrew, before I let you get a word in edgeways on this.
That's all right.
Is I'll have a look at the website of the Astronomical Society of India, because that's the Society of Professional Astronomers and other professionals from related disciplines. It's now 50 years old, founded in 1972. A very well-known Indian astronomer, Vainu Bapu, as the founding president. And I don't know what their membership is now. It was 1,000 a few years ago. It's probably well in advance of that. They're a very active society. There are radio observatories and optical observatories in India. There's a lot to look at. So yeah, have a look at their website and check it out, Kabir.
Yeah, and good luck to you. And after all that, if your parents want to get in touch with Fred and tell him what they really think, I'll give you his address. But no, look, I was always told find something you love and turn it into a career. And I'd always loved radio, and I still do. And I did it I've been doing it. I still do it for, what is it now? Coming up on 40 years. And I had some good jobs and I had some bad jobs, but overall, I did what I loved, and that's and I got paid for it. So that's really what you should strive for, I suppose. And your heart seems to be going towards astronomy. And look, I think the future of astronomy is unlimited, especially when we get into space exploration. They will need astronomers out there. They'll need them on the moon soon. You might need to consider that. There's just so many possibilities, I believe.
Quite so.
But yeah, and look, our regards to your parents, Kabir, and thanks for the question.
Yes.
Now, our final question this week comes from Jerry.
Hello, Space Nuts. This is Jerry from Kamloops, BC. Love the show. I had a question about star populations. The oldest stars are population 3, and the newest stars are population 1. Seems a bit backwards to me, and I was wondering what will happen next. Will the population 1 stars die with the end of the universe? Will it go into negative numbers? Would love an answer. Thanks, guys. By the way, Andrew, if you want people to believe that you're a bad golfer, you shouldn't show your golfing trophies on the podcast. Also, are those hole-in-one trophies I see? Awesome work. I'd love to hear the stories about those too. Keep up the work. Great work, guys. Later.
All right. Thank you, Jerry. They're over my shoulder. You can see them in the background there on my little trophy case. All the ones up the top are cricket. I don't know. I've got 3 holes in one. The first one was a 2-iron from 180 meters, 200 yards. It just landed slightly short of the green, rolled up over the shoulder of the bunker, and went down the hole like a rabbit. My second hole in one was a 9-iron from 125 meters, which went over the pin and sucked back into the hole. And my third one was a slam dunk, went in on the full. And so I've been lucky enough to have 3 holes in ones in my career. And that one there, the cup, that's my one and only championship. I've been runner-up 3 times, but I finally cracked one. So that's my one and only championship. So, yeah, I used to be better. I'm not so great at the moment, but, I used to be a pretty decent golfer. I still hit the ball all right, but consistency has let me down in recent times, Jerry. So, and that's because I just don't play as much as I used to. So maybe soon when I play a bit more, things will change. We'll have to wait and see. But I think age will have an impact in there as well. Tend to slow down when you get a bit older. Anyway, enough about that silly stuff. Let's answer his question about star populations. I find this interesting. You might want to sort of expand on what he's getting at before you answer it.
It's golf, isn't it? That's what it's all about.
Yes.
Yeah.
Lots of stars in golf, and I'm not one of them.
So, it's a great question, and good to be reminded about this stuff. So, population, the idea of star populations goes back to the great astronomer Walter Baade, who started off in Hamburg, I think, and moved to the United States before the Second World War, and became one of that country's leading astronomers. And during the Los Angeles blackout during wartime, he was able to use the Mount Wilson telescope free of any light pollution. That's the 100-inch. It was then the biggest telescope in the world, to take photographs of the Milky Way, particularly the center region of our galaxy and the galaxy generally. And what he identified, and he did spectroscopy as well, so he looked at the spectral makeup of the light and was able to identify different elements that are present in these stars. He identified these 2 populations. Population 1, which is stars typically like the sun, which live in the disk of our galaxy and are relatively rich in what we call metals. Metals are anything other than hydrogen and helium. So, the normal elements, iron, magnesium, sodium, all of those things very much very present in, or very obvious in stars like the Sun. But then he found this other population of stars which he called population 2, which are much less, which have far fewer of these elements present in their spectrum, in their light. And he interpreted this, the modern interpretation of this is that those stars are so old that they were formed in a time before the interstellar medium was enriched by these heavier elements from supernova explosions and previous generations of stars. So the more what we call metal poor, the ones that have got fewer of these non-helium and hydrogen elements, they are the ones that we think are the oldest. They also sit in the galactic center. They sit in the halo of our galaxy as well. So it was an extension of that, I guess, probably during the 60s, 70s, maybe even a bit later, that led to the idea of a population 3, which are stars that are so old, they are the first stars that appeared in our galaxy after the formation of the galaxy, after the formation of the universe, in fact, 13.8 billion years ago. So the population 3 stars are the oldest. We haven't found any yet. We found some really metal poor population 2 stars, and some of the colleagues I worked with on the RAVE project a few years ago, they were very interested in those really highly metal poor stars, ones that have virtually got nothing other than a little bit of iron in them, as well as the helium and hydrogen. But population 2 would just be helium and hydrogen, and population 3, and they haven't yet been found. So I think Jerry's question was, what happens to them all? All of these stars will die out one day. The oldest ones probably the ones that will be the first to die out because they're so old. Whereas stars like the Sun will be going for another 5 billion years. I suppose a massive red dwarf stars, which are fairly evolved. That's to say, they are like population 1. They are going to be the longest lived. They typically have lifetimes in excess of 20 billion years, 30 billion years, something like that.
That's incredible.
Yeah.
Mm.
Sorry, a long answer to a short question.
Yeah. What was the answer again?
Yes, the answer was yes.
Yes. All right. So we have not found population 3 at all. We just have a theory as to what they would be. Could that mean that they've already died off?
It's possible. Yes. It's that they're the ones that typically probably population 2 stars. The massive ones would have died off within a few million years. They're long gone. But it's the more modest ones, very metal poor dwarf stars, which may be the ones that are the first population 3 stars that are discovered, because they're long lasting. Small stars last a long time. Okay. And it's just possible, Andrew, that the James Webb Space Telescope will be the first instrument to detect a population 3 star.
Wouldn't that be great? Yeah, I'm sure. Yeah,
I'm really excited.
Yeah, I'm really excited. I think we're going to have this explosion of new information in coming years. I really do. It's fascinating. And just popped into my head, what is the shortest lived type of star?
Well, very massive ones. They basically live fast, die young. They burn their energy very rapidly, get to the end of their lives, and there's a collapse, which in the most massive stars causes a supernova. And they would be population 1 stars.
Yeah.
Yeah.
And so they're called population 1, 2, 3 because of the sequence of discovery. Is that right?
It's more. It was just Barda
cycles.
Yeah, I suppose actually, yes, that's a good way of putting it. We knew more about population 1 stars from the earliest days of astrophysics, the ones that are like the Sun.
Yeah.
And a few of the others were found then, but nobody really knew what they were. And it was Barda himself who categorized them. Populations 1, 2, and then population 3 followed, based on what we know about stellar evolution, the way stars evolve. There
you are. All right. Thanks, Jerry. Thanks, Kabir. Thanks, Mike, for sending in your questions. We wish you all well, and Kabir, with your career choices. yeah, lots of luck, and look forward to hearing from you in the future. Maybe you'll discover something. The Kabir Watson comet, maybe. Who knows? Who knows?
Yeah.
Now, just a reminder, if you have questions for us, you can send them to us via our website, spacenutspodcast.com. There are a couple of options. You can click on the AMA tab at the top, or you can click on the Send Us Your Voice message on the right-hand side. I've made a weird discovery that with this interface we use, I can play MP3 files, but I can't play WAV files. So I'm going to have to do some converting. We've finally figured that out. It's only taken a couple of years. Also, while you're on our website and you want to look into supporting us in a financial way, you can become a patron, which is easy as just clicking on the Support Space Nuts button. You can visit the shop while you're there, catch up on all the latest astronomical news through Astronomy Daily. And I want to send a special shout out to the group that has formed on Discord. Discord's not something I'm overly familiar with, but one of the users, who refers to himself as Mighty Spaceman, has taken it upon himself to create a Space Nuts community on Discord. And so they, like the Facebook group, chat with each other about astronomy and space science. So a special hello to our supporters on Discord. Thanks for getting behind us. And thank you, Fred, for all that you do and helping us out every week with Space Nuts, with all the information and answers to questions and career advice, you name it. Thank you very much.
Yeah, the only thing we don't do is relationships. That's all.
Not yet. Not yet. All right, Fred,
Yeah.
Thanks so much. We'll catch you next week.
Sounds great. Thanks, Andrew.
Fred Watson, astronomer at large, part of the team here at Space Nuts. And of course, we say hello and thank you to Hugh back in the office, who pushes all the buttons and rings all the bells and orders the donuts. He's the only one there, so he eats them all. From me, Andrew Dunkley, thanks so much for your company. We'll catch you on the very next edition of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.